Okay, this is the second problem. See, three vectors are given a, b, and c, and you are asked to find a dot b cross c. So, what is a dot b cross c? A dot b cross c is basically a box product. That means if you have three vectors, geometrically it looks like this. For example, suppose you have a, b, and c, right? If you have three vectors like this, okay, a, b, c, and if you make a parallelepiped using these set of vectors like this, for example, geometrically let me explain. So this is the a vector, this is the c vector, this is again the c vector, okay, and this is the b vector, okay, and this is the a vector, this is the a vector, okay, and this is the vector a, and if you join this, okay, so this is the parallelepiped formed by these three vectors a, b, c, and the volume of the parallelepiped is actually the box product a dot b cross c. Now what we need to find is a dot b cross c, and simply the technique is you go to my lectures and you will understand the technique. A dot b cross c is simply just take the determinant with the coefficients, right? The coefficients of a are 2, -3, 7, and b is 1, 2, 0. Then it's for 0 it's 0, 1, and -1. And if you want to find the determinant, this looks like this. So this is 2 times 2 into -1. So 2 into -1 minus 1 into 0, -3 -3 times 1 into -1 -1 minus 0 into 0, plus 7 into, so 1 into 1 minus 2 into 0. So that is it, right? And so let me write it properly. So this 1, right? It's 1 into 0. Bracket is closed. Okay, fine. So first term is 2 into 2, 2 into -2, that's -4. The second term -3, then you have another -1, so that's -3. And the third term 7 times 1, so that's +7. So that's 0. Now see, this is very interesting. Now if you have a box product whose result is 0, so basically, so the volume of this parallelepiped is 0. That means these three vectors, this a, b, and c, okay, they lie in a plane. They do not make a volume, they lie in a plane. If they lie in a plane, so naturally they will not make a volume. So my way of teaching is, you do the problems, right? You do the problems, and simply you will understand the theory. So this volume, okay, so this volume formed by these parallelepiped, this volume is basically 0. So this volume is 0, and thus these vectors are coplanar. In another way you can also say that, so this implies these vectors are a, b, and c are linearly dependent, or they are coplanar. So if they ask you that whether certain vectors are coplanar or not, you don't have to show that the linear combination, some coefficients of A, some constant multiplied with A plus some constant multiplied with B equals to C. So you can also show it like this. Just take a determinant and show that it's 0. If it is not 0, then it's linearly independent and they are non-coplanar. So I hope you understand this. Thank you.